All right, well, let's begin. First of all, the applicable announcements here. Friday is a big day for us, so today's Wednesday. 2 days from now, you will be taking your second midterm exam. Homework 10 is due at 11, but the exam itself becomes available at 10:30 a.m. So that's a 2-hour window that you'll be able to access the exam on Blackboard. I won't email you the exam. You just need to log on and obtain it directly from Blackboard. And you can use your textbook, you can use your notes and previously completed homework assignments, but you must work individually on the exam. And then any hand calculations you'll need to scan as a PDF file, and anything that you've used Microsoft Excel for, you should upload the .xlsx file to Blackboard. And so then all of that needs to be uploaded before 12:30 p.m. And so, if you wait until 12:30 p.m. to submit your exam, then that'll be too late. And I will not be particularly charitable if that happens, because I consider this exam a 45-minute test. And so somebody who is waiting right up to the last minute, I won't have much sympathy for. So, any questions related to the test before we talk about the replacement and retention studies today? All right. Well, if you do have any questions that pop up, anything you're wondering about, you can send me an email or give me a call on Teams, and I'd be glad to address it for you. All right. Last time in class, we learned about economic service life analysis. And what you learned is that you should own a piece of equipment for the number of years that minimizes your cost. Remember that the two components that contribute to total cost are the capital recovery costs, which have to do with the initial purchase and the disposal, meaning either salvage or market sale of the equipment at the end of a certain number of years. So that's the capital recovery costs. And then the other component of total costs are the annual operation and maintenance costs. And so I provided a template file, and we went through the process of determining what's the optimum number of years to own something. Now, we just did it for a single item in Monday's class. Today what we're going to do is apply those same methods to perform a study on whether to retain a piece of equipment or whether to replace it. So on the left you can see kind of an old-timey photo that may be a chemical plant or a refinery of some sort, where you have an operator in a control room manually keeping track of pressures and changes and temperatures. And so it's a very maybe labor-intensive and non-automated system that's represented here on the left. More recently, computer controls and remote sensing is being used to automate a lot of these same processes that in the past had been manually operated. And so the picture on the right, you can see that they've got a lot of screens and the entire system is diagrammed out. And there are a number of terminals where a user could sit and interact with the system, but the picture kind of meaningfully doesn't show a person sitting at the controls. A lot of the same things that would require user input are automated such that when you have a computerized control system, the amount of human interaction required is significantly lower, and so then that may be cause for a reduction in your operation costs. So the question is, when you have one of these old systems, even if it's still functioning okay, how do you know how much longer to own it? The United States government is kind of notorious for having some software systems that are really just spectacularly old. And one such computer system that sometimes gets criticized is the control systems that are used for nuclear weapons. And some of those programs were conceived of in the 1970s and implemented in the 1980s, and still now, 40 years later, are controlling nuclear weapons. And so they know that those systems haven't failed yet. They haven't accidentally launched a nuclear weapon in the 40 years that they've been in place. And so some people have the argument, hey, don't Don't fix it if it's not broken. And then other people say, well, you could have improved reliability and better interoperability with the current computer systems. And so, there's pressure both ways to keep the old system or to replace the old system. And so what we're going to do today is look at a means of economically analyzing and determining how long to either keep something or when to replace it. So our objective in this analysis, like before, is to minimize cost. We assume in this analysis that both the defender and the challenger are able to meet the required specifications, meaning that you can generate, like if this is a fuel refinery, you can make gas with the old system or the new one, but the difference, we're going to analyze the difference, is how much it costs to operate, repair, and in the case of the new system, how much does it cost to purchase the replacement. So you may remember that we went over some terminology during Monday's class meeting, and the defender is the system that you already own. And when you keep it, you assume that it does have a first cost. Even though you already own it, if you continue to own it, then the opportunity cost is that you're not able to sell it. And so in the analysis that we're going to do today, when we're comparing two different options, the first cost, remember, of the defender is its market value right now. Now the challenger, on the other hand, is going to have an initial purchase price, and presumably, hopefully, it will have lower operation and maintenance costs, and that's part of the reason why there's a motivation to consider some new piece of equipment. We have two different categories of replacement studies. There are replacement studies where a study period is specified, that is, how many years we need to analyze this equipment over. And so, it may be that you want a piece of equipment to be available for a 10-year horizon. And so in the case that you do have the study period specified, then the idea with the defender would be, let's say we know we have to have something in place for 10 years. And maybe we'll own the defender for 1 more year. Maybe we will own the defender for 2 or 3 more years. We're not exactly sure how many years we'd own it, but at some point it will be replaced. And then for the remaining years of that specified study period, then we would purchase the challenger and use it for the remaining 9, 8, or 7 years. So that is if you do have a specified study period. In other examples like our first in today's in-class exercise, there isn't a specific study period, and you just own the equipment for as many years as minimizes your cost. And so that'll usually be either set outright in the problem statement, or you can infer from the context of the data whether there's a fixed study period or if there's not a specified study period. So what we'll do in the first instance on our in-class exercise for today is a study where there's no specific period. What we'll do is we're going to do the economic service life analysis. And remember, what that is where we are trying to figure out the total annual worth of costs for a certain number of years of operation. So we're going to find out for both the defender and for the challenger, how much do both pieces of equipment cost on an annual basis if you own it for just 1 year, or for 2 years, or for 3 years. We're going to analyze a whole great number of years, and then we're going to pick whichever alternative minimizes the total cost. So our decision criteria is select the alternative, whether it be keeping the defender or purchasing the challenger. So whichever one gives you the lowest total annual worth of cost. And so now here in bold, this is important that you understand each component of this phrase. So total cost means, remember, that there are two components that go into that total cost. The first component being the capital recovery. The second being the operation and maintenance costs. So by total, we mean both of those things combined together. Now, annual worth means that we are taking that initial purchase price and the market sale value, and we're annualizing it. So we're finding the capital recovery, which by definition is an annual amount. But then the tricky thing is with the operation and maintenance costs, because generally those start low and gradually get higher over time. You know, if you own a piece of equipment for 1 year, its operations and maintenance costs will be pretty low. But the longer you own it, the costs are going up and up and up as it breaks down more and needs more replacement parts and needs refurbishment or servicing. And so although the cost is going up each year, we want to annualize that, meaning we want to take all of those costs, which vary over time, to the present, combine them at the present, and then spread it back out over the number of years of ownership so that it's an equal annual series. And we did that on Monday, and we're going to get some more practice with it today because it's an important concept. And I'd like you to have some additional practice doing this economic service life analysis. Now, this is kind of simplistic, the setup that we're going to do today. In the real world, you won't know exactly how long to own the equipment because the data is always changing. Like you can do a economic service life analysis for a piece of equipment, and it may say, you know, now, today, at year 0, it may say, own the equipment for 6 years and then sell it. In the real world, what you do when you got an answer like that is you'd say, all right, well, I'm keeping it this year. And then next year, you'd perform the analysis again, and you'd double check what are your actual costs and what would be the updated value for the anticipated market value of the equipment. Because when you're making an estimate 7 years in the future about how much the maintenance is going to cost in each of the future years and how much the sale value of the equipment might be, I mean, you're just kind of guessing in a way, and hopefully it's an educated guess and you're using realistic data that can be supported with past experience or looking at what's for sale out there on the market now, or going to the records of your maintenance department and figuring out how much you spend on average to service that kind of equipment. So hopefully you have justifiable estimates, but still projecting into the future is subject to updates over time. And so what you would do in the real world is you would every year do a follow-up study just to make sure that it's still worth keeping the Defender and that the tide hasn't changed in favor of the Challenger. Okay. So with that background, oh, I just realized I have my audio muted, so if anybody asked a question, I wouldn't have been able to hear it. Buy the car. Okay. Believe me, it's on my mind for sure. All right, so we're going to do the in-class exercise today. Let me bring it up. This is the one. We're going to start with a scenario where the study period is not specified. In-class exercise 28. Replacement study. I sent out a template file that has the setup for each of these columns. So essentially you don't have to type it in yourself. So we're going to do the economic service life analysis, same as we did last time, and here you can see I've given you the kind of the reminder of what goes in each column. So what we're trying to figure out is whether to replace a robotic system. We already have the Defender. We currently own equipment that if we sold it today, we could get $15,000 for the equipment that we own today. And so that is going to be the first cost of our Defender, because if we end up keeping our current robotic system, then we are foregoing the opportunity to sell it for $15,000. And then it says here that the value, the market value, declines by 20% each year for 3 years. So think about what that means. If it has a current value of $15,000, then that means the market value after 1 year is going to be 80% of $15,000. So 0.8 times 15,000 means that the market value in year 1 would be $12,000. And then 80% of 12,000 is the market value in year 2. Then 80% of the previous year will give us the market value in year 3. So that's how we determine column B, is with the statement that the market value is declining 20% each year. Then we have the operating costs. 20,000 for the first year, 8,000 for the second year, and 12,000 for the third year. So it's not a consistent pattern. Maybe if we want to keep our robotic system for that first year, then there's going to be a refurbishment that we're kind of wrapping into these operational maintenance costs. So that's going to go into column C. And then column D through G is where you start applying the same procedure as we did last time. And of course, I am going to demonstrate that today, but I'm going to pause and not narrate through that because you've seen it once already and maybe even started on the homework. So I'd like you to get a crack at doing that both for the Defender and then below that in the template file that I sent out today. Let me see if I can open up that template file. All right, here it is. So you're going to do it first for the Defender and then also for the Challenger. And so the data that we have for the Challenger includes its first cost, its anticipated useful life, and then a statement about how its market value is going to decline each year. So remember, its market value is a positive amount, whereas the cost is a negative amount. And then we have some information here about the operating costs starting in year 1, and then increasing by means add an additional 2,000 on top of the original operating costs for each subsequent year. Now this is no study period specified, so we're just going to own the equipment for as many years as minimizes our costs, and 10% is the discount rate that's used to analyze this. Okay, so I'm going to pause the recording and pause my talking to give you a few minutes to go through these calculations. And the question is, what should we do? Should we keep the Defender? Should we buy the Challenger? And how many years is the optimal? Should we keep the Defender for 2 years? Or should we buy the Challenger and own it for 4 years or 5 years or whatever? The question is, what action is going to minimize our cost of ownership? Okay, hopefully you're working away and don't need any assistance from me, but if you're completely stumped or at a dead end, go ahead and watch what I'm doing. I'm not going to narrate through it because I don't want to disturb those of you who are walking, but I am going to start putting the calculations into my own start file, and you can follow along if you like. So what should the company do in this case? What decision should be made about the defender versus the challenger and how many years? Even if you're not able to get those numbers as quickly as I've just done it, hopefully you're able to interpret the results and pick an action. So what is our decision criteria in this analysis?
We're trying to minimize costs, so
Very good.
look at a challenger. It looks about year 4 is the
Okay.
lowest, and that'd be like a decision criteria right there. Total annual worth of costs.
All right, you're right. We want to minimize cost. And so if we were going to go with the challenger, then 4 years of ownership would minimize the costs. But what's even cheaper than that? What's even cheaper than buying the challenger and keeping it for 4 years?
Looks like keeping the defender for 3 years as
Exactly.
negative 17. So
That's right. And so so our ultimate decision, since this has no study period, so we're not told in the advance that we have to keep it for a certain number of years. It's just we're going to go with whatever is the lowest, regardless of the time frame. And so the ideal choice here is to keep the defender and own it for 3 more years from now. So that's the answer here. What should the company do? The company should keep the defender for 3 years. All right. So any questions about that?
Yeah, I have one question.
Please go ahead.
Can you go over how you got column D? Because I keep doing it and I get a different number.
Yep.
I don't know what I'm doing wrong.
That one's tricky because when we're setting up the NPV function, I anchor the top cell but not the bottom one. So I will show you how I did that. So I'm just going to delete that out completely. All right, so what we want to know is we're going to find the present value of, like this operating cost right here, the 5,000, that's in year 1. 7,000 is in year 2. 9,000 is in year 3. So what we want to know for each row is if all of the amounts up to and including that year are discounted to times 0, what's the equivalent amount in year 0? So for the first year, it's going to be the NPV, and the rate, refer up here to the interest rate. We'll anchor it. And then for the first year, there's just this one amount. Since we're in year 1, only that year's operating costs are applicable inside the function. So I close it. And so what that means is a single $5,000 payment in year 1, if it's discounted to year 0, has an equivalence of $4,545. Now,
I did that same thing and I got 4,950.
do you have 10% or 0.01 or 0.01% for your interest?
It says 0.01. That's probably why.
All right. So it was just the interest rate then. All right. So let me just show how to do this second one because I would imagine there may be some other students who have questions about this next part. So equals NPV, the rate, 10%, anchor the reference, and then for the amounts, you'd highlight both of those first 2 cells because if we're in the second row, that means that we are experiencing both the first year cost and the second year costs. And so both of them are in the range. But I'm going to anchor the reference to C20 so that when I drag it further down, it keeps looking at C20 as my first amount. And then as I drag it successively down through each additional row, then instead of C21, it would be C22, 23, 24, however many years I drag it down through. So I'm only anchoring the first cell in the range. And then when I apply it through the others, we'll take a look at how it's handling 6. For example, you can see that it's still looking at the interest rate. And it's still looking up here at C20 as the first year, but then as I've dragged it down, it now has all of the different operating costs. All right. Okay, so that one I think was related to the interest rate. Are there other questions about how to do certain things? The other, I think, tricky one is the capital recovery. Did everybody get the capital recovery okay, or does somebody want to see it again, how we did that? Lim asks, can you explain to us why the company should keep the Defender for 3 years? Yes, because we look at this column of total costs, and we want to have the lowest amount. And so of the Defender years and the Challenger years, looking at all of these, your objective is just find whichever one is the lowest. So this is the lowest one, and that means that's what's going to minimize your company's costs, is to keep the Defender and own it for 3 years, because that's cheaper than if you buy the Challenger. No matter how many years you own the Challenger, none of those costs are as low as just keeping what you already have, keeping the Defender and owning it for 3 years. Other questions? All right. If there aren't any other questions, let's move on to the second part of this in-class exercise. So we just did one where the study period was not specified. Next, we're going to do a replacement study where the study period is specified. And we have the same decision criteria, that you're going to choose the alternative with the lowest annual worth of costs. But what's different here is that we have to provide some level of service for a 10-year horizon. So if we keep our old system for however long it's operable, the remaining years we're going to buy the new system. Now, this example is a little bit complicated, and so we probably don't have time to do the whole thing independently. I think rather maybe what would be the better choice is for me just to show you what the calculations look like in an example like this, so that you can see, you know, how it's set up and just be basically familiarized with the logic and the thinking there. So we'll read through the problem statement together, and then we'll also look at the solution. All right, so here's the options. If you buy the new thing, it's a navigation system. The new thing has a cost of $750,000, operating costs of $50,000 per year. It lasts for 10 years, and then it has no market value. So there's no salvage. So that's pretty simple. It's the same operating costs every year, an initial upfront cost of $750,000, and then at the end of its useful life, it's worthless. And so if we just look at the cash flow diagram for the Challenger, that new system looks like this. An initial purchase price, annual operating costs, and then it's over. All right, the existing system, this existing navigation system that we already own, has a present value of $70,000. And remember that when you own something that has an existing value, then if you keep it, you're foregoing the opportunity to sell it. And that opportunity cost is why we consider it as an outflow, is because you've lost the opportunity to sell it if you keep it. So you'll notice here in the cash flow diagram, the first thing that we have in time 0 is that present value at time 0. The problem statement says that what we already own, this existing navigation system, can be used for 3 more years at an operating cost of $30,000 each year. So for the 3 years of life that it can remain, you've got 1, 2, 3 years of an annual operating costs of $30,000. Now, for whatever reason, it's only going to be functional for 3 more years. And so then what we would need to do is we would need to purchase a replacement. And this $146,475 is the thing that we're going to buy as a replacement. What we are given in the problem statement is that the replacement navigation system we'd purchase has a capital recovery of $146,475. And so you can think of this as sort of like the contract services. In a way, it's similar, because we're saying we're going to buy this new item for the remaining years, because we want both of the options to have the same time frame. We want the same 10-year service window. And so this new navigation system has a 10-year life, but the remaining 3 years of its life, you can see these dashed arrows, that just means that it's going to be put into a different project. And so the remaining 3 years of its life aren't applicable into our comparison. We only have to consider the capital recovery for years 1 through 7. And then there's the annual operating costs as well. So essentially, this $146,475, that is the Challenger. That's the cost of the Challenger after the useful life of the Defender. So option 1 is just buy the Challenger now. Option 2 is keep the Defender for 3 years and then buy the Challenger. So the question is, should you buy this new navigation system now, or should you buy it after you use up what remaining service life you've got in the existing system? All right, we're going to use another 10% interest rate here. And so let me show you the analysis that we stepped through. I hope I've got that handy. I think I probably do. All right, so if the study period is specified, then the Defender let's see, from the cash flow diagram, zoom down a little bit. All right, the Challenger, we've translated the cash flow diagram into a cash flow table. Let me make that a little bit bigger so that the numbers are easier to see. So the Challenger, $750,000, then 10 years of our annual operating costs. And we do the NPV function to that, where anything that's in the future is discounted to year 0, and then the amount that's already at time 0, this $750,000 is outside the NPV function. And so the total present value of the Challenger is $1,057,000 in costs, whereas the Defender, we've put this cash flow diagram into a cash flow table. So there's the initial $70,000 opportunity cost, our operation and maintenance, and then the combined annual operating costs of $50,000 per year, as well as the capital recovery costs of owning the Defender. And so we want to minimize the costs, and so this is the present value of the costs for each option, and then I've annualized it by using the payment function, so that we're going to find A given P with the payment function. And so if we take that lump sum amount at time 0 and then spread it back out over the 10 years of operation, you can see that keeping the Defender for 3 more years is going to bring your costs down considerably. Instead of buying the equipment now, it's new, keeping the old equipment for a couple more years is going to bring the expenses down. And so then the decision that we should follow in this replacement study is that we should keep the Defender for 3 years and then purchase the Challenger and use up 7 years of the Challenger's operative life, and then transfer the Challenger to some other owner for the remaining 3 years of its capital recovery. So that's how we would do a similar process if the study period is specified. And I think an important point for doing this when the study period is specified is try and prepare a cash flow diagram so you can easily see, translating the statement in English into a diagram where all of the amounts are clearly laid out there before you is really going to help to set up the table correctly. Does anybody have any questions about the comparison if we do have a study period specified? Well, if not, that's all we have for today. Remember, okay, hint to problem 3 in homework 10. Let me pull up that homework assignment and I'll see if I can give you a hint. Problem 3. Well, yeah, I'm glad you asked about that, because as I'm looking at it, what I'm realizing is that we won't actually cover the topic on this until next Monday. And so I apologize for that. I shouldn't have included it on this homework assignment. So all you'll need to do for the homework assignment is the first 2 problems. I'll change the one that's posted on Blackboard, but it'll just include the same 2 homework assignments, because budget limitations, now that I'm looking at our schedule, that will be the subject of Monday's class meeting. So thanks, Lim, for asking. You don't need to do problem 3 for Friday. I'll put that on to the next assignment that'll be submitted later. Ethan asks about homework number 1. And do you have to have a total cost column? So on homework on this first problem, it's very similar to the in-class exercise that we did. Let me bring up the cost effectiveness analysis, because I think you're going to be able to mimic that solution and that procedure almost identically. So let me refresh my memory of where I've got the solution for that one. All right. So, no, that's cost effectiveness analysis. So this was the one where we were doing, like, comparing the different NGOs and arresting poachers. And so on the problem that you're asking about, you'll follow the same approach, where the only difference would be that it says in the problem statement on the homework that there's 52 weeks per year. And so this is the number of units produced per week. And so what I'd suggest that you do is you should find out how many units do they produce in a year. And so you know the salary per staff and the number of staff members. And so the cost is going to be salary per person multiplied by staff. And then the effectiveness will be units produced per week multiplied by 52 weeks per year. So it's going to be cost in the numerator, the effectiveness in the denominator, and then your top priority would be identifying the one that has the lowest cost per effectiveness. And Lim, the answer is yes. You should find out the units produced per year, because it says here that you want to find out your cost effectiveness ratio in terms of salary cost per unit produced. And the only way to do that is if you take the production numbers from a weekly basis to an annual basis. So because of the units I'm asking you to find the cost effectiveness ratio in dollars per unit, you will have to convert it from per week into per year. All right, it's 11:49. I don't want to keep you past our cutoff time, so that's it for today. Remember, the big announcement that you need to keep track of is that the exam will open at 10:30 a.m. on Friday. So 2 days from now, you'll be finishing up the exam. You'll only have about 40 minutes remaining that you could work on it. So if you have any questions between now and then, feel free to get in touch. Take care, everybody. Bye-bye.